board there. If okay, so exponential function y equals f of x is b to the x. More generally, y equals a b to the x. We're going to call that exponential also. We've got this table of values. We're going to apply an important characteristic of exponential functions here. If your x intervals are of constant length, then I'm going to say the y ratios are constant. Okay, now what do I mean by the y ratios? I mean the ratio of each number in the y column to the preceding. So y ratios here for our example are 70 over 100, badly written, 49 over 70, and 34.5 over 49. Okay, now are these ratios constant? Okay, in decimal form, /70 over 100 is 0.7. /49 over 70 is 0.7, and 34.5 over 49 is 0.7. X intervals are all of length 3, so the table represents an exponential function. Okay? Now we could determine which function. We saw last time that we can do two simultaneous equations and get the function. Okay, we could take any two of these points then and plug it into the form y equals ab to the x and solve for a and b. Okay, I could say the points (3, 100) and 12, 34.5 lie on the graph. And we plug the coordinates of those points into the form y equal ab to the x to obtain the system of equations. Okay, we have 3, 100 means y is 100 when x is 3. And y equals 34.5 when x is 12. And it's y that's equal to 34.5 equals a b to the 12th. and so on. Okay, so we could get A and we could get B. So A turns out to be approximately 141, and B equals, actually, I can't give you a really good approximation to B. It's going to be the cube root of 0.7. Okay, and that's approximately equal to, I think, probably 0.89. Because the cube root of 0.729 is 0.9, and just a little less. Maybe as low as 0.88, but I think it'll probably round off to 0.9. So our model for this table is y is approximately 141 times 0.89 to the x. And you can take any of the x values in this table and plug it in here, and I think you're going to find that the result is going to be pretty close. Now there's some round off error, and then there's estimations in my head error, and those estimates aren't totally accurate. Now the 141 is pretty accurate. Okay, it's not too far off. Don't know about the 0.89, and remember you're raising this to not large numbers but not small numbers of powers that are in the range from 3 to 12. So there could be some error in that. However, and let's see, 141 is going to be maybe a little bit low. No, it rounds off to 141. Okay. So, just an example of how we can test a table to see if it's exponential. Again, the test is, first of all, make sure the x values that you select are equally spaced. Okay, and these are equally spaced, 3 units between each x value and the next. And then test whether the ratios of the y values, this divided by this, this divided by this, this divided by this, are all the same. Then, if you find out that it appears to be exponential, you can do what we did last time. Take 2 points, consider those to be points in the graph, plug them in to the form y equals ab to the x, evaluate a and b, you get your model.